All right, so here's part 2 of 4.3. In the last video, we took a look at the horizontal shift, the stretcher compression factor, the number in front of the x squared, what it does. And we looked at adding a value after the x squared and seeing how that shifts our parabola up and down. But we'll take a look at more of that again in this video. Which is more exact? Just get our minds warmed up here. Which is more exact, the root of 21 or the never-ending decimal 5.85, 0.582575695, and continue, because root 21 is irrational. So the more exact answer here, the proper answer would be root 21, because that is including all the decimals to infinity that occur. Whereas if you have to write the decimal out, at one point you're going to have to round or stop short. So that'll be more approximate. Which numbers are equal here? Well, we know 1/3 is the same as saying 0.3 repeating. This is terminating. It's just 0.3. So that's not the same. 0.333 also terminates. 0.3 repeating is similar. We know 33 divided by 66 is 1/2. That's not going to happen. That's not the same thing. And 3 to the negative 1, you might recall that means that little negative there means inverse. So there's an invisible 3 over 1 there, and we invert the fraction and make the exponent positive. So 1 over 3 to the power 1 is exactly the same thing. So that also is equal to 1/3. And for the third question here, which is preferable to write? I'm explaining this because when we're writing our final answers or quadratics or equations, we're not going to use mixed numbers. We're not going to write with repeating decimals. We're not even going to use decimals. We're going to keep our fraction improper and in lowest terms. Okay, so that's the preferred way to write, and that's the method we're going to be using. The learning goal, we've covered a lot of this already in the last video, but just to let you know, what we're going to be looking at is the parent parabola, y equal x squared. We're going to look at what the k does, right? The vertical shift up and down, the a value. We're going to cover that in a moment. And there's the horizontal shift. And there's a little bit of a combination. We have a horizontal shift and some up and down movement. We can also change the a value, which is hiding right in there. Okay. So you look at the parent parabola, y equal x squared. We talked about in the last video that the a value in front of it is just an invisible 1. But that can also be changed. We can have a 1/2, which would mean it's compressed, rising slower, okay, or increasing at a slower rate. We can have it stretched more than 1, so 2, 3, 4, and it can go up doubly fast or quintuple, etc. Right? But the a value in these equations is actually hiding right there. Right now, it's still an invisible 1. So although the parabola has a horizontal shift or it's moving left or right, it hasn't been stretched or compressed. It's just the same size and shape, or what in proper math language, it's congruent to the parent parabola. This equation would also indicate that it's congruent to the parent parabola because the invisible a or 1 in there, the number 1 is hiding right there before the bracket, which means it hasn't been stretched or compressed. If it were again greater than 1, 2, 3, 4, 5, etc., it would be stretched or skinnier. And if we're less between 0 and 1, less than 1 and greater than 0, for example, a 1/2, a quarter, 5/6, 3/8, etc., then it would be a compression, okay, because it's increasing at a slower rate than 1. Let's take a look below here just to summarize. This link again is the link to the slider if you want to play with that and see what happens with the equation, with the h value, the a value, and the k value. But for y equal x squared, again, y equal x squared, remember that's the parent parabola. And it asks here y equal x squared, and there's a plus k at the end. That k value, you might recall from the other video, the k value is what increases the parabola up and down. So we did x squared plus 2 here in the red, right there. I'm just circling it for you on the screen. That plus 2 is the parabola that is right here, okay? And the vertex shifted up 2. So that k value, we could have made it y equal x squared minus 2, and then the parabola would just be down below at -2 in that territory. But same size and shape, x squared minus 2, same size and shape, just shifted down 2. If we said x squared minus 5, it'd be, instead of at 0, 0, it would shift down to 0, -5. If we said y equal x squared plus 10, then the parabola from 0, 0 would shift all the way up to 0, 10 as the vertex, but the shape wouldn't change. Okay, let's go back to our handout. So in this case, what does the k value do? The k value is the vertical shift relative to y equal x squared. I'm going to show you on the screen some completed, more detailed answers, and you can pause and record the answers then. Y equal ax squared. What does the a do? Well, we just talked about the a value. If we put a 2 or a 3 or a 4, it makes it skinnier. If it's between 0 and 1, it would make it compressed. Okay, again, like you push down on the arrows. The a value, again, you remember from the last video, if the a value is positive, then the parabola opens up. If the a value is negative, then it opens down. So the a value tells us two things, whether it's stretched or compressed relative to the parent parabola, but also tells us the direction of opening. Positive opening up, negative opening down. The final one here is the horizontal shift. What does the h do? It shifts left and right. Remember, if I'm shifting to the right, my h will be a positive number. So let's pretend I shifted my parabola, and I'll just here, this is just a quick sketch of the parent parabola. That's y equal x squared. Let's say I wanted to shift this to the right to 1, 2, 3, and draw the parabola here. What happened? Well, by shifting to the right, we're saying that we're now at 3. So the h value is now a positive 3. So my equation would be y equal, in brackets, x minus the 3 squared. And it looks confusing because you're saying it looks like x minus 3 potentially, right? You think minus or negative might mean it went left. But the equation for horizontal shift is x minus h. What would happen if we went left 3? Let's sketch that for you here. If we went left 3, then now we're saying that we're at -3 for our vertex. So it shifted 3 units left. My h value would technically become that -3 has to go in here. But we remember our equation says x minus. If you change x to -3, minus negative becomes plus. So this in brackets here would actually end up being x plus 3. Again, looks a little bit counterintuitive. If it says plus 3, you might be inclined to think that it went to the right. But again, it just means that your h value is negative. Indeed, you went left. The mental hack, again, is just to look at that. Say if it says plus, it means it went left. If it says minus, it means it went right. Okay. Now I'm going to pull up my handout, and you can pause the video if you wanted to copy the completed version of that, a little bit more detail. You can pause the video and copy the more detailed answers for that handout right there. Okay. And now I'm going to go to our final handout for 4.3 day 2. And based on what we've learned so far, let's see if we can sketch a few of these together. So a good summary of knowledge here. Y equal x squared, it says sketch the graphs of that. So we're going to, in all of these, we're going to be sketching the parent parabola. So again, just a quick sketch like that. Remember the parent parabola, when x is 1, y is 1. If x is -1, y is 1. When it's 2, it's 4. -2 is also 4. We're not going to fit 3 squared and -3 squared at 9, but this is a general ballpark sketch of the parent parabola. But if we have a value after the x squared, like the -3 here, do that in red. If we have -3, remember, that's the k value, y equal x squared. In this case, the k is -3. It just means that we went down 1, 2, 3, and the parabola is still exactly the same size and shape, opening up, because the value in front of the x is still an invisible 1 and positive. So that didn't change the direction. All that's happened is this parabola is now down 3. Let's take a look at number 2. If we sketch the parent parabola again, just as a point of reference. Okay, we've got the parent parabola, and now it says it's x minus 4. Moments ago, I explained that if you have -4, it means that that 4 value is positive because our formula, our equation is x minus h. And someone's telling us that our value for h is 4, which means it went 1, 2, 3, 4, and it's sketched there. We know it hasn't been stretched or compressed. These are a little bit tough to draw sometimes. I try to draw them from the vertex. I find it more difficult to draw in one fell swoop, but you do what works for you. So this parabola here has shifted to the right 4 because that's a 4, right? So I try to draw them from there, and it hasn't been stretched or compressed because there's a hidden invisible 1 in front of the bracket. So it's the same size and shape. Again, we call that congruent to the parent parabola. This is an example of where the parabola gets stretched. So I'll draw the parent parabola again, a little sketch of that. And then now there's a 3. So remember in the table of value example that we use, when we have a value greater than the invisible 1, for example, here, this purple example, when we have a value that's greater than 1, for example, we had 2 here, 2x squared, everything was doubled. So you take a look at, I'm going to try and just look at or highlight that portion for you if I can. You take a look at the purple one. Relative to the blue parent parabola, this purple one here is skinnier because it's gone doubly fast, okay? Or double the pace of the parent parabola, we can say. Here, let's look back at our handout. This is now 3 instead of 2. So remember, when for the parent parabola, if I plugged in 1 for x over here, if I plug in 1 for x, 1 squared is 1. But now we're saying it's 3 times that. So instead of being at 1, 1, it's at 1, 3. Okay? Instead of negative 1, 1, it's negative 1, 3. Instead of when 2 or negative 2 is squared is 4, now it's going to be triple that, which is 12. We won't even fit that here. So I'll just catch that from the first. And basically, that's going to look a lot skinnier. Okay? And this is a compression. Again, we'll sketch the parent parabola, and you can use this to practice your sketching. And if it's 1/2, we had that similar example in the previous video and the other handout that I provided online. 1/2 means that it's compressed. So instead of being 1 squared is 1, it's now going to be half of 1. Instead of negative 1 squared being positive 1, it's now half. Instead of 2 and 4, it's now going to be at 2, 2 or negative 2, 2. And what you can see here is that it's being compressed. It's going out at half the rate of the parent parabola. So that's a compression. Armed with that knowledge, and by the way, again, there's the A value has been changed, but in this case, the A value in this example here was positive 3, so the parabola is still opening up. Here it's positive 1/2, so it's also opening up. If that were a negative in the middle there, negative 1/2, that would be the same thing, just opening down. Okay, it still be compressed, just opening down. Now, armed with the information that you've gathered in the 2 videos so far, we're going to write the equation based on the transformation that's been applied, or the translation that's been applied. So it's telling us that the parent parabola, y equal x squared, has been stretched vertically, that's the math terminology, by a factor of 9. Remember, the stretch or compression is affected by the A value. That's what tells us what happens. This was stretched by a factor of 3. So to be stretched by a factor of 9, all that's going to happen is that's y equal 9x squared. And that's it. If it's compressed vertically by a factor of 1/9, well, this one here was compressed vertically by a factor of, I'll erase that negative there, by a factor of 1/2. So a compression, again, is the A value that tells us the stretch or compression. So this is going to be y equal 1/9 x squared. Be careful to write your x squared in the middle with the division line. It's not down below. It's not 1 divided by 9x squared. It's 1/9 x squared. If we're translated 6 units to the right, remember the equation is y equal x minus h squared. If it's gone right to 6, then the h just becomes a 6. Y equal x minus 6 squared. Okay. Now I'll challenge you in class with a few more translations and see if you've got a deeper understanding of it. Thanks for tuning in. Hope that video was helpful.